So now we arrive at example number 35. Wow, JEE 2015 mains. And what did it say? Oh, difficult question. Two stones are thrown up simultaneously from the edge of cliff. Maybe stone is thrown vertically, right, from the edge of cliff. One is that is thrown u is equal to 10 meter per second, and second stone is thrown at 40 meter per second. U is equal to 40 meter per second, respectively. Which of the following graph best represent the time variation of relative position of the second stone with respect to first? That means it is showing distance travel at time t y2 minus y1 as a y-axis and x-axis at t. Oh, difficult. Assume stone do not rebound, that is fine. And g is 10 meter per second. Wow, g is 10 meter per second square. JEE 2015 main the question was asked. Oh, let's solve it. So acceleration is given negative, g constant, u is positive. Initially, stones are thrown at constant velocity, both are positive. So v decreases linearly, x in the convex, that is fine. V velocity decreases, and x become convex because here acceleration is negative, so this shape is convex. This shape should be convex, right? Now here we know that distance travel is equal to s is equal to ut plus 1 of at square. So for s1, u is s1, distance of this tower, height of this tower is given. This tower is given s1, distance is given. Then a stone is thrown like that vertically upward. So u is given, u is given 10. T1 we don't know how much time it will require, and here acceleration become minus g. So S1 is minus 240. Direction we have to consider for the entire journey, for the full journey that we already studied previously also. And 1 half A is equal to minus 10t. If we solve this equation, we will be having T1 is equal to 8 seconds. T1 is equal to 8 seconds. Similarly, another stone is thrown simultaneously at U is equal to 40 meter per second from the similar height. So minus 240 is equal to 40 T2 plus 1 of minus 10. And we can get T2 is equal to 12 seconds. See, ultimately, we know that T1 is less than, smaller than T2. That we know very well. See, up to T1 travel means for the first 8 seconds, both are stone on air. Both the stones are on air. Right, both the stones are on air. That means if we take the difference, see we got here s is equal to ut plus 1 of at square. If we take distance s2 prime minus s1 for the first 8 seconds, if we take distance for that, for the first 8 seconds, so we can put s2 is equal to value is equal to u is 10 t1 minus 40 t1, or you can take 40 minus 10 is equal to 30 is equal to 30 t1. If you see here, this graph displacement difference is directly proportional to p. So that graph should have linear position, linear movement. The first movement should be linear. First movement should be linear. Wow. Then after 8 seconds, means 8 to 12 seconds, the first turn is not having any movement. So first turn becomes zero, stay movement becomes zero, and only it is having turn number two. Only it is having movement of turn number two, and here when it is having G is negative. G is negative. It is having convex shape. It is having convex shape. It is having convex shape. So this is the shape is like convex. And velocity is also negative because it is a returning journey. Velocity is negative when the object moves in downward direction. So for negative, we need negative slope. We need negative slope of this. So this is negative slope. This is negative slope. That means we require only this one side. We need this one side. So see, this calculation is just to show you how it works. Simply, you just need to do this T1 is always less than T2. Fine. So at or up to T1, both stones are on air. So at that time, you can have S2 minus S1 is equal to 40 T1 minus 40 T2 because acceleration portion that will be cancelled. It is equal for both and this will be cancelled. Right. So here up to this portion, it is having linear. So yes, it is linear. It is having linear. It is having linear. It is having linear. It is having all are having same equation. So this calculation you are not required. What we required, we just required to have once the first stone is on the ground, second stone is still moving on air up to some distance. It has to travel and it is having minus g, and therefore it possesses this kind of convex shape, convex shape with a negative direction. So this one is correct. Therefore, B is correct. Therefore, B is the correct one. So now we have example number 36. JEE 2005. The given graph shows the variation of velocity and with displacement. Oh, see, up to now we already have graph A versus T, acceleration versus T. But this graph is velocity versus X and acceleration versus X. Oh, this is something different. So what is mentioned? Which one of the graph given below correctly represents the variation of acceleration with displacement? JEE 2005. The question was asked. So here, see, graph is given velocity versus displacement. Velocity versus displacement. The relation is given linear. Great. So from that, we know that y is equal to mx plus c. Y is equal to mx plus c. Line equation m. If you wanted to have m, so can we say this y is equal to v, x is x, fine, x is x, fine, m is equal to tan theta, x is equal to tan theta. So theta, this is the theta, so it is negative. Tan theta, it is giving negative. This side, perpendicular side, v0 divided by nearer side, x0. And c interceptor, y interceptor when x is equal to 0, x is equal to 0 when x is equal to 0. This is v0. Wow. So we can put here v is equal to minus v0 x0 x plus v0. We know that acceleration is equal to dv by dt. So dv by dx is equal to dx by dt. See, this kind of examples we solved before also. And dx by dt is equal to v. Acceleration is equal to v dv by dx. dv by dx. So we have value of v. Do we have value of v? Yes, we have value of v. Put this here. Do we have value of dv by dx? We can differentiate this. Why not? We can differentiate it. So minus v square by v0. It just remains this one portion. Put this here. Right? Let's simplify this equation. So can we say minus minus plus v square by x0 power 2 x minus v square by x0. Can we take this equation like y is equal to this is m, x minus is plus. So here m is positive, m is positive, m is positive, m is positive, slope is positive. Is it positive? Yes, it is not there because it is not representing slope. Here let's check this slope, this slope, this slope. Theta is greater than 90. Wrong. This is greater than 90. Wrong. Oh, only one option. A option is that. This is correct. And also you can find this is minus, interceptor is minus, so it is also here negative side. Right. So answer A is correct. Oh, oh, oh. Wow, what a question. Difficult. Oh, one more question. The area under velocity time graph between any two instants t is equal to t1 and t is equal to t2 gives the distance covered in the time dt t2 minus t1. Wow. So option A is given only if the particle moves with uniform velocity. See, it is given like that in the velocity v time graph. Whatever area under this region gives displacement, right? That we know, or distance covered. The condition is given only particle moves uniform velocity. If uniform velocity it is there, so v is uniform, then only it is applicable. Second is that uniform acceleration. If acceleration is uniform, then it is applicable. Only if the particle moves with an acceleration increasing at uniform rate, or in all cases, irrespective of whether the motion is one of the uniform velocity or uniform acceleration. See, it is simple, yeah. See, under the area velocity gives always give distance covered, irrespective of any condition. It is just a summation of all the velocity multiplied by time. So it is true, irrespective of whether the body has uniform velocity or non-uniform velocity, whatever condition. Area under the acceleration, no, sorry, velocity time curve always gives its distance or displacement. Oh, one more question. 38. The variation in the speed of a car during 2 hours of journey is shown in the figure. Yeah, but this one is figure. The magnitude of the maximum acceleration. See, for the maximum magnitude acceleration, you just need to find which theta is bigger, which slope is the, you can say, the tallest, the steepest. For the AB, it is 0. Which theta is the biggest? Which theta is the biggest? You see here, this BC line is having a biggest theta, right? Answer is BC. Answer is BC. Simple. One more example. So in the graph is shown in the figure magnitude of the acceleration. So graph is VT and the slope gives acceleration position. Which one is the maximum? You just find the slope. Slope. Which slope is maximum? B slope. It is having this one. If you consider the C slope, yeah, C is maximum. 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 If you see, B is having small positive, D is having small negatives. Slope C is largest. Small C is largest. Therefore, answer C. C is the correct answer. C is the correct answer. Example number 40. Oh, we reach up to 40. All India pre-medical test. A particle shows distance time curve as given in the figure. The maximum instantaneous velocity of the particle. Again, we need to find the slope. We just need to find the slope. Which slope is the biggest? Which slope is the biggest? You can see here this one, this one, this one, this one is the largest slope, and therefore C is giving the maximum. One more example we have JEE 2018. Ooh, all the graphs below are intended to represent the same motion. One of them does it incorrectly. Pick it up. JEE 2018, it is asked. Wow. Let's solve it first. Let's solve it first. So first, if we talk about the first, it is giving velocity versus time. So initially, velocity is positive. Why? Then momentary it becomes 0, and then it becomes negative. It's okay. It happens. There is nothing wrong. You can just take an example of ball. Ball is thrown vertically. Velocity is positive and reduces. At top it becomes 0, then it goes down and negative velocity increases. Negative velocity increases. Fine. So first one, no issue at all. Right. For the first, no issue. For the second, it is the graph is velocity versus position. So we know that velocity is starting with positive and it is starting with 0 position. Fine. So here if you see this is the h, if you take h is equal to 0 and here h is maximum. So in the position from that with velocity start with 0 position and that increase velocity decreases, position increases. So here the similar case velocity decreases, height increases, and there velocity becomes 0, position is maximum. Then velocity is 0, velocity increases in negative direction, and then it is going down, down, position h is 0. So h is 0, fine, h is 0, h is 0. Yes. So B is correct, A is also correct. There is no issue with A and B. Then let's check graph number C. So it is having dual motion, we can see here. Half shape, it is like that. It is having convex. It is not convex, it is concave. It is concave, yes. So that means if there is a concave shape, simply acceleration should be positive. Acceleration should be positive. We have taken examples for the case 1 and 2 in which it is like a free movement of body on under gravity. So g is should be acceleration should be minus g, and therefore first half the graph is concave but it should be convex. So therefore this is the wrong. This drawing is wrong. This drawing is wrong. This drawing is wrong. Right. So graph C is incorrect. Graph 4, position versus time graph. The distance, of course, it initially it's starting from a 0 with time, going on the top position with the time reaches to top position at 0 and then it goes back to 0 and after some time, yeah, it is correct. It is correct. It is correct. So only C is wrong. Only C is wrong. And the correct graph it should be here. See here. The correct graph is shown here. Initial shape should be like that. Initial shape should be like that. It should be a convex. Initial shape should be convex. Then it can go with concave shape. That is fine. So we have example number 42. A ball is dropped vertically from height d above the ground. So see, suppose a ball it is taken here. It is dropped vertically in the downward direction from height d. It hits the ground and bounce up vertically. It hits the ground. It hits the ground and bounce up vertically up to what portion? D by 2 height. Right. Neglecting subsequent motion of air resistance. Its velocity v varies with height. So again, it is given v with x, distance or h, right? So total is h, or you can say d. Fine. JEE 2000. Great. So if we consider this situation, you can solve this by using this equation also. You can solve this equation also. Why it should be solved by this equation? See, you can also take directly acceleration is equal to minus g, so that your curvature should be convex. Curvature should be convex. Wow. But it is applicable when you draw graph velocity versus t. May not be applicable here. Let's see. So first is vertically drop the ball, and we know that v square minus u square is equal to as, right, and we know that initial velocity is 0. So v square is equal to 2s, and s is directly proportional to v. That means it gives some concave or convex shape. We can identify from that, right? So it is a parabolic shape. Curvature is not, it's not a straight line. We can identify it is not a straight line. Then for the stage one, when the ball drops from the top, initial u is equal to 0, acceleration is equal to minus g, and it is having negative velocity after some time, right? So velocity decreases. So velocity, simply you can say decreases, or you can say increases in the negative direction, or vertically downward, right? So in the first case, velocity starts from the 0. If you check this velocity, is it starting from 0? Yes, it is starting from 0 and it is decreasing. Fine. So this one can be okay. Velocity is not starting from 0, so this one is wrong. The third one is, see, the shape should be either concave or convex, so C is also incorrect. D, we can see velocity is not starting from 0, so this one is also incorrect. Only A is having option as a correct. But let's see again. So distance decreases. So distance is maximum, it is here. D is equal to here maximum, and when it moves downward direction, so distance becomes 0. Distance decreases. So we can see here, for that distance, is it decreasing? Yeah, distance is starting from maximum and it is decreasing along with this. Yes, so this one is correct. In this distance, it is not decreasing. Distance is decreasing. Yes, distance is not decreasing. Right. Similar, similar. Stage number two, ball bounces up vertically to height d by 2. U is equal to positive velocity. U is not equal to 0. G is negative. So what we can do, vertically decreases. Direction is positive when the ball bounces up. U is positive and G is negative. So velocity decreases from the maximum. So here it is d by t, we can take, or not d by t, sorry, v by, it is having some lesser velocity, right? And decreases with height, decreases with height, increases. Yes, so this one is the correct, this one is the correct. So distance increases from 0 to 2, right? So from moving 0, it increases to d by 2. It is increasing somewhat half d by 2. So therefore 1 is correct. Answer 1 is correct. You may also solve once again, right? With a calm mind. You can get this answer within this step. As I mentioned earlier, from this step, you can get the answer. So one is, it should be a parabolic shape, or simply you can say concave or convex. So therefore this answer is incorrect. Second is that v starting from 0. So velocity should start from 0 for the first interval. So you can say yes, starting from 0. For this, it is not starting from 0, or here it is also not starting from 0. So answer A is correct. Directly you can solve this question easily. Again, understanding is given here like that. See here, from 1 to d, v increases. So v increases in the downward direction, right? Along with h decreases. Side 2, velocity changes its direction and magnitude. 2 to 3 decreases upward. So velocity decreases moving upward. So h increases. This is not so simple. It is somewhat difficult to understand, as we are habited to work with V to T diagram, but not with the other diagram. So you have to change this habit also. Again, the question is from similar question was asked in JEE 2019. So the velocity v of a body moving along the positive x direction varies with the displacement x from origin. V is equal to k root x, where k is constant. Which of the graph is presenting? See here, it is given, equation is given, v is kx. So we have to convert this into vt graph or maybe a t graph or xt. We cannot use here v to x because our final graph is having x to t. So we have to have conversion for that. So we just have to have differentiation for that. dv square by dt is equal to k square dx square. We can take this differentiation. So 2v is equal to du by dt is equal to k square v, and dv is equal to k square by 2. That, see, the similar example was also solved during motion in a straight line, and that was asked in JEE. We can take integration on both the side, integrating v dv k square by 2, and integration, we know that v is equal to that integration. We can get the solution like that. So v is equal to k square by 2t. We can get this solution. You can solve. You may try. So here you can see velocity is directly proportional to t. Velocity is directly proportional to t, and v is positive. Right? Velocity is directly proportional to t. That means line is linear. Line is linear. So this two options are not required. Second is the slope is positive, so you can directly take the slope theta. It is less than 90, so it works. But here theta greater than 90, so it won't work. B won't work. So answer, we have one more example, example number 43, and the similar question was asked in JEE 2019, and we already solved this kind of question while solving motion under 1D. So what is asked? The velocity v of a body moving along the positive x direction varies with displacement x from the origin. So equation is given, v is equal to k root x, where k is constant. See here equation is given, k v is equal to k root x, and we need to find here slopes from x versus t, x t graph. So we need to convert this equation either in terms of vt or in terms of x t. Right? Otherwise, you cannot solve it directly. It is not possible to solve it directly. Let's see. So v is equal to k root x is equal to v. We can just take square on both the sides. So v square is equal to k square x. Then dv square, we can differentiate. We are differentiating this term. dv square by dt is equal to k is constant. We can take outside k square dx. So it becomes 2v dv by dt is equal to k square v, and dx by dt become v. Right? So now we need to have dv on one side and the opposite side other thing. dv is equal to k square by 2 dt. We can take integration on both the side. dv, here it is not v. So 0 to v dv k square by 2, 0 to. So it becomes just v is equal to k square by 2 t. So we got here velocity as a positive. From that we can identify velocity as positive, and acceleration is also positive, and acceleration is also positive. So for that positive acceleration, what should be shape? It should be having a concave shape. It should have a concave shape. That means concave shape. And velocity is positive. That means theta should be less than 90 degree. Slope should be positive. So when we are talking about slope, for this slope, if we take this, so this theta is less than 90 degrees, so this slope will work. Just compare, this is not the one, this is not the one, x versus t, because here velocity is directly proportional to t. That means x, it is not, it should have curvature, it should have proportional to somewhat, x should have proportional or t square or something like that. So first two options are incorrect, first two options are incorrect, second and c and d is possible. For the c and d, this is the correct, we already checked. So this is the shape, yes, and this is theta less than 90 degree, yes. This c is answer is correct. Right. So you may further also, you may go with this, or you may continue v is equal to dx by dt k square by 2t. Again, you may do differentiation for the same, and you can get x is equal to k. So x is proportional to t square. We already identified from this region also. The similar case from the graphical representation. No further. So x is proportional to t square, hence option C is correct. Hence option C is correct. Great. So up to this much is sufficient. You can go with this. But yeah, question was really difficult. But we have to practice for that. Oh, we are at the last question, example number 44, and some statements. Statement 1: a body moving in a straight line may have non zero acceleration at an instant when its speed is 0. Statement number 2: if a body is thrown vertically upward, its speed at the instant when it reaches the highest point is 0, but its acceleration is 9.8 meter per second. Statement 1 is true. Statement 2 is true, and statement 2 is the correct explanation for statement number 1. Is it correct? Statement number 1 says that a body moving in a straight line may have non-zero acceleration. May have non-zero acceleration means acceleration is not 0, but velocity is 0. And we know that, right, when a body is thrown vertically, at when it reaches to top, velocity is 0, but acceleration is equal to minus 9.8. Minus 9.8. So it is given here, if a body is thrown vertically upward, its speed at an instant when it reaches to highest point it is 0, but acceleration is 9.8. So statement 1 is true. Fine. Statement 1 is true. Acceleration can be non-zero and velocity can be 0. But statement number 2, right, is also true. Both are true. Fine, both are true. So statement number 2 is correct explanation for statement number 1. So I do not agree with this. Here, statement number is true, but statement number 2 is not correct explanation for statement number 1. How? How? See, acceleration, it shows a rate of change of velocity. Acceleration is show rate of change of velocity, delta v divided by delta t. It is showing rate of velocity. That means what? See, at this position, velocity may be 0, but just before and after, velocity was not 0. So acceleration is just rate of change of velocity. Not at this point. It is changing, it is measuring nearby places, and therefore acceleration can be 0. Right. So here at the top position, velocity can be 0, but acceleration is a change of velocity delta v by delta t. So we are comparing with nearby position, not the same position. Therefore, see, statement 1 is true, statement 2 is true, but it is not a correct justification. Correct justification is delta v by delta t should be acceleration, and therefore at v is equal to 0, but at nearer point delta t, v is not equal to 0. Therefore, it gives acceleration. So thank you for watching Physics Ka Doctor. Please subscribe to Physics Ka Doctor.